Okay, good afternoon, everyone. It's a pleasure to be here with you today. My name is Xinyu, and the subject of my talk is HLE SLAM for overexposure construction environment. Firstly, we talk about the visual SLAM. Visual SLAM can create a map of an unknown environment and the location itself using an RGB camera, and they can work in a construction set. And the existing visual SLAM and such as ORB SLAM 2 or ORB/3 performance varies in both the dataset and the real world experiment. And we can see in the picture and in real light construction environment, the robot can use the visual SLAM to create a 2D poster graph. The color line is the visual SLAM result, and the dotted line is about the ground truth. We can see there are not a big errors. So it can perform well, but in overexposure construction set, it poses a significant challenge for visual SLAM. And when robots use the visual SLAM to location, it gets big errors in the 2D poster graph. So why it happened? Because in the overexposure environment, a large number of feature points and information are lost. And we can see in this picture, red part is a view light. We can get many feature points, but in overexposure parts, we lost the information and feature points. There are no green feature points in the overexposed part. So there are existing three problems about the overexposure lateness. The first is automatic exposure camera can lead to the poorly exposure image in challenging lateness scenes. And second is about the camera exposure control algorithm is limited in the case of the changing lateness. And the third is about the visual SLAM are designed for the normal light and the rich texture. It works in overexposure lateness and not show the good result. And the existing solution about overexposure lateness have three methods. Firstly, and it used post or processing on overexposure images. And second, it used some constants of the lateness vectors for feature points detecting and matching. But these two methods are not recovered the information from the lost and overexposure part. It just helps the visual SLAM to detection and matching the feature point. And the third method is about the automatic adjust the overexposure parameters. And in some cases, it can get a good result because it's just the parameters, but in some environments, they cannot adjust the camera parameters get a good result, and it also shows the overexposure images. And in our in our method, the HLE SLAM compares the three parameter components. First is we use the double camera frames, and we do some frame overexposure fusion, and we use this fusion frames and tracking and location mapping. Firstly, we get the high and low exposure dataset. We use the two different cameras. One of the cameras used the built-in program parameters, and the other limited the overall brightness of the images by limited the maximum overexposure time of the camera, so we can get the high overexposure frames and low exposure frames. And the camera is placed vertically, and we only keep the part of the images where the two cameras overlapped. Okay, and we used three critical to select the best brightness level for two images. We used the contrast exposure and information entropy value to generate the final images. And we do some experiments in public datasets. We used the original MAV datasets, and we increased the brightness value about the MAV dataset, and we get the overexposure dataset. You can see in the frames there are many overexposure images, and we use the HLE to recover the overexposure lightness. And we can see the gradient and feature point results of the original overexposure and HLE method. Our method can get a good feature point result. Okay, there are a demo about the overexposure and HLE in overexposure construction sets. We can see in this video, our method can get a good many results and overexposure in overexposure part we can get a good result. And due to the strong sunlight in the window and floors, and in this 2D graph we can see our method, the HLE is a blue line, we can get a good result, and the red line is the overexposure lines, they just and have a big errors. Okay, and we used an overexposure filter method to recover lost information and help the construction robots in tracking feature points and in overexposure environment. And we valued our HLE SLAM in public static and relay construction environment, and our method successfully deal with problems about location errors. And our method can process information in real time using mobile computers, and is well suited for dealing with diverse overexposure challenges and in many construction environments. Thank you. That's all.